Hi students, this is Shivakrishna, working as an assistant professor in Civil Engineering Department, Andhra Engineering College. Today I am explaining the topic of Unit 5 in Structural Engineering 2, that is Design of Steel Structures. The coming to fifth unit, we are already learning about the previous units. What is the types of connections and what are the tension members and how to design the compression members and how to design the plate girders. These all are explained in the previous units. Now coming to fifth unit, that is trusses. When these trusses are plays a very key role in the practical point of view, and any particular one structure in steel, trusses are very important construction of more economical structures steel structures like bridges and shelters and roofs. So these all are making with of trusses only. This is the very important design in the trusses in the particular structural engineering. Here in the architectural and structural engineering purpose, a structure, it is a structure comprising a one or more triangular units. It constructed with a straight members whose ends are connected to at the joints referred to as nodes. The truss, it is a combination of nodes and members. In here, external forces and reactions are those forces which are considered to act only in the nodes, and as that results the forces in the members which are either tensile or compressive, it should be both are acting on that particular scenario. In that situation, the type of movement should be acting on that nodes and forces. In the type of trusses, the load acting on the frame, on that frame, it should be bending moment will be occurred on that particular scenario. That movement it should be excluded because all the joints in the trusses are treated it as the revolute joints. Why? It is combination of two nodes, that is called two members, that is called as truss. In herely, a truss has the following three characteristics. The one truss, it should be mainly depending upon the following three characteristics. That is one of the axial loads. The truss should be acting more axial loads only, and loads are applied at the endpoints only. This type of trusses loads not acting on the middle point of that members. Then the load should be acting on the middle point of that frame, middle point of that member, that is called frame. So here truss, the load acting on only joints only. So elements are joints by pins only. This type of joints mostly like as pin joints only. If you have see some pictures of the trusses, this is the structure. This is the N framed type structure. See here, number of vertical girders and horizontal girders and vertical brass, and some of the inclination will be seen in this figure. Here some of the inclination will be included, that is 45 degrees to bracings it should be provided, and this should be across the river. It should be crossing the river from between to that to this end. We are using the N type of stretches or framed stretches. So here some of the types of planes should be plane stresses should be here, that is the open plan and storage and asymmetric and double bobtail and purlin beam and king post and purlin beam and queen post, warren post and extended type. These all are some of the basic type we have to use on the basic need. We are providing this type of trusses. Here most commonly used that very commonly used king post and queen post, where the span of that truss we should be very low. In that situation we are providing the king post truss, and coming to span will be more very more like more than 12 meter span have to provide in that situation. In that situation we are using to queen post trusses. And coming to planar trusses, planar means here it is a single plane, not in a multiple plane. It should be have a single plane. It are often used to support roofs and bridges. In the roof trusses, the roof load is transmitted to the truss at the joints by the means of series of purlins. Purlins, it is the uses to supporting that principal draft. And what is the design? Here in this particular truss design, we are assuming the some elements. That elements it should have plays a very key role in the particular truss design. Here the design both the members and connections of a truss. It is the first. necessary to determine the force developed on each member when the truss is subjected to a given loading. In this regard, these assumptions will be made. What is the assumptions mean? First of all, load are applied in the endpoints only, and the second one, weight of the elements is neglected, and the third one, elements are jointed by pins only. These three basic assumptions are very important to design of a truss and axial loads only. Why? Because the truss should be maintained only axial loads only, not only any transverse loads, this type of loads not bearing the truss. Only it should be capable to resist the only axial loads. If the force tend to elongate the member, it is a tensile force, and where it has to shorten the member, it is a compressive force. What are the problems in here? How much force acting on the truss, very important here. The force is applied at the center of a member of the truss. It should be must divide into two equal forces, that is F1 and F2, force 1 and force 2. So F1 and F2, that should be divided by 2, so that is called F by 2. Here see here figure, the total load acting on that particular beam, the total load should be divided into two equal parts, that is force 1 and force 2 should be applied on that particular frame. When a force is applied along the member but is not its center, it is divided as follows, like this. It should be not maintain any center of the load, it should be maintained some eccentricity, that is called eccentrically loaded member. So in that situation, how to find out the force on that particular frame? It is called B by A plus B, or it should be A by B, A plus B. We will assume all the internal forces to be in the tension. Then after solving the problem, the positive forces or the tensions in the minus forces are compression. So it is to calculate the internal forces on each member of the truss and state if the members on the joint and compression is using the two methods. What are the two methods means? Joint method or nodes method or section method. uh, uh, Not only notes method and not only section methods, one more method is also this, that is in facing in the special cases, that is zero forces moment, it should be acting on that particular cases. In that situation, when you look at the truss, you can determine the following: F equal to 0. So in that situation, the in the situation, the equilibrium forces will be acting on that particular situation. So how to solve the truss problem? First of all, you have to maintain the free diagram of the truss. On that free diagram, what should type of load should be acting on that particular plane, it should be finalized. Okay, so first of all, draw the free body diagram, yeah, already you know, and calculate the external forces on the support reactions. On that free diagram, how much load acting on that beam we have to find out, and due to that force, how to acting on that such reaction should be on the particular supports we have to find out. In that situation, we are using the nodes method. In this node method, you should have to first you have to find out the how many nodes it should be involved in that particular truss, you have to find out. In that situation, the whose number unknown forces does not exist any two, then study is equilibrium using the static equilibrium equation to determine these forces, that is summation of x equal to 0 and summation of fy equal to 0 and summation of moment also 0 if you have to assume. Go to the next node and the study its equilibrium using the evaluated forces from the previous node, then go to the next node and so on. For the method of sections, take an imaginary section to cut the truss into two pieces in condition that the number of unknown forces does not exceed 3. What are the three? Some of the external forces in x direction is 0, some of the external force in y direction is 0, and some of the moments also 0. These three equilibrium conditions are maintained to one piece of truss. After determining this all forces, the positive forces are tension and minus forces it should be assumed as a compression. For example, Determine the forces on each member of the truss if the state if the members are tension compression. So in this figure, the some of the forces should be acting on the joints and some of the sections acting on the nodes. In this situation, with this type of it should be tension or compression, it should be positive or negative if you have to find out. See here, on the truss, in the top elevation motion, 600 Newton should be acting on the G joint and 900 Newton should be acting on that E point, and some of the members like reaction should be acting on AX and AY. In this particular situation, the total members should be defined. How many members here? 1, 2, 3, 4, 5, 6. 5 members are there here. 5 members means 6 joints should be there. See here, first you have to find out the reactions at the A and B. Some of the moments equal to 0, you have to equilibrium equation. In this situation, two distance, it is two spacing. By into 2 plus 900 load should be acting on the 2 spacing, plus 600 should be acting with the spacing of 4 meters. So here, say a summation of Fy equal to 0. So sum of the moments of the sum of the forces A minus B equal to 0. Here A equal to B. In this situation, A equal to negative 2100 newtons and it should be converted into positive, and BS equal to B equal to 1500 newtons should be acting on that plane. See here, on that reaction AX equal to 0, F1 equal to 2100, like it should be represented as the positive, so there should be tension zone, and by submitting in the equation 1 we get Bx equal to 1500 newtons, and node D, this should be acting on that situation, and node D F6 force 6 should be acting on the situation, plus 600 equal to 0. In the situation that 600 should be coming to right side, the F6 equal to 1346.6 newtons, and based on that equilibrium equation, F2 should be acting on that scenario, and it should be C equal to 0 force member on that F3 equal to 0, then F6 and F5 it is the likely compression force only that should be acting as that 1341.6 newtons, and node E, it should be inclination will be occurred in here, it should be applying the sine rule. F4 sin 45 equals negative 900 newtons, right, because it is the compressive force, and that F4 should be compressive nature, that should be 1272.8 compression it should be acting. So here there should be total load acting this particular scenario, all types of forces acting on that particular situation. In that situation, some of the positive will be there and some of the negative will be there. In should be positive, it should be represented as the tension members or tension forces, and the negative value it should be represented as it should be as a compressive forces. This all node 1, node E, node D, node C, it should be all the loads should be acting here, and due to that load the sum of the reaction should be acting on that particular scenario. Here in this figure 900 should be acting on that E, and that should be reflected also C and B also. Why? Because the junction of that node should be acting on that particular members, and in the topmost 600 newton should be acting on the D node. In that situation, it should be reacting on that A and B. Why? Because it is a combination of A and B. Two plates are overhanging to one another. In this situation, the total loads it should be distributed through the positive and negative signs. It should be the total load should be acting to positive changes to compression and tension point of view. In this situation, the total load should be acting like this. Here some of the members also redundant structures also we have to face in the realistic problem. In that situation, when the redundant means m equal to 2j minus 3, when the members are more than the joints, that should be resultant frame. When the joint should be greater than the members in that particular truss, that should be termed as unframed. Why? Because it is not sufficient to joints and members. So in that particular situation, when the members are very high in that particular scenario, the total load it should be capable that members only. In the situation, the trust should be very safe in zone. In this situation, the load acting on that particular scenario also very important. In this situation, this type of basic problem should be practiced in the field. This type of same formula and the same applicable to realistic problems, and more number of forces should be acting on a particular stress. We have to find out on that scenario. Okay, yeah, this is the for node A and node D. Next, node C acting on that forces F5 and F6 also same, and node E also same. Okay, so these are the differences to find out the problem in that particular scenario. And here applying the F4 means it should be applying the sine cosine sine formula. That should be load acting to 45 degrees you have to consider. And that important in this unit Perlin design also very important. In that Perlin designs it should be capable to carrying the whole vertical loads acting on that particular stress. So that is the very important to design. Okay, this is the stresses and types of stresses and what should forces acting on that, and how to find out the loads, movements, reactions on the particular stress. Okay, this is about the fifth unit. Okay, thank you students.